We are at the final lesson of this unit. Even though it's titled Perfect Square Trinomial, it is really a culmination of everything we've learned in Unit 8 and up to this point, all combined together. On page 509 in your textbook, you will find a very, very useful table. Please use that as a reference tool. Okay, we're going to now break it down. We're going to look at something. The other day we were talking about the difference of perfect squares. Now we're going to be talking about perfect square trinomials. You have already been working with them. I just maybe didn't call them a perfect square yet. So let me break this down just a bit. This is your A term, and you're going to ask, is this a perfect square? Then you will go to the C term and ask, is this a perfect square? If the answers are yes, your next test to determine if you have a perfect square trinomial is the B term twice the product of the square root of the A term and the square root of the C term. Now I do realize writing words in math sometimes can be a bit much. It's so much easier for me personally to apply it to numbers. I flip back in my notes to what we just started lesson 9.5 with. We started by talking about, we took x plus 4 and squared it. And when I was done, I ended here. Is this a perfect square? Yes. Is this a perfect square? Yes. I'll come back in just a moment and touch on that again. Then we did 9 or x plus 9 squared. That means we took it times itself. Is this a perfect square? Is this a perfect square? So far, yes. It even worked when we did this with subtraction. X minus 5 squared. Is that a perfect square? Is that a perfect square? So we're going to talk about it, but we're going to come right back to this in a moment. Let's apply it to a math problem again. To me, doing problems makes more sense. So I will ask, well, I always am going to ask this first. Can I make it simpler? Is there a greatest common factor I can take out? No, there isn't a number that goes into 25, 30, and 9. Then I might ask myself, is 25x squared a perfect square? Yes. Is positive 9 a perfect square? Yes. Now I want to run the B term through that test. Is 30 2 times the square root of the first term times the square root of the last term, or C? Okay, so is that 2 times 5 times 3? Woo! It does equal 30. That is very exciting. That means to factor this, it's very straightforward. I will take the square root of the first term, the A, so I would have 5x. I'm going to take the square root of the C term. Square root of 9 is 3. And then it would be squared because it's a perfect squared trinomial. Now, I will take the sign in front of B, and it would go there. Wow, that's a lot. That's a lot of stuff I just did. Well, let's come over here and test it. If I take 5x minus 3 times 5x minus 3, will I get back to where I started? So I'm going to FOIL. And I know you're experts at this. We have to combine the center terms. So I get 25x squared minus 30x plus 9. I just went really fast. I'll pause a minute here let you get caught up if necessary. So I did go back right to where I started. I knew I had to have a negative sign here because my center term is negative, so I would need negative there. Turning back to this lesson, is 8, to give the B a test, 2 times the square root of 1, because A is 1, right there, times the square root of 16. Oh, 2 times 1 times 4 is 8. That is a perfect square trinomial. Is 18 2 times the square root of 1 times the square root of 89? Is 18 2 times 1 times 9? Yes, that's a perfect square trinomial. Took the sign in front of B. Now I have a negative 10, not a big deal. Is that 2 times the square root of A times the square root of C? 2 times 1 times 5 is 10. So these are called perfect square trinomials when you have a binomial squared. Now, you're probably thinking, whoa, how much can my brain handle? Remember, it is always an option to just go back to what we know. We can go right back to the ACB chart. That will work every time we are factoring a trinomial. I would do A times C, so 9 times 25, and I get 225. I usually think of money when I do that. And I need a sum of negative 30. Okay, so I could do 1 and negative 225. We know that doesn't work. I could do not 2, but 3, and 3 goes in there 75 times. I add those. I do not get a sum of negative 30. 4 does not go into 25. 5 goes in there 45 times. Let me see if I did that correct. 6, 7, and I would keep testing, but I know that it's going to be, oops, all of these need to be negative because I need a positive product. Negative 15 times negative 15. Those add to negative 30, multiply to positive 225. So I would have 25x squared minus 15x minus 15x plus 9. Remember, this is your A term. These two together make the B, and that is your C. Step 1, group. So I will just group. Greatest common factor would be 5x, so I'd have 5x minus 3. Ooh, I have opposite here, so I know you need to take out a negative, and I would have 3 to take out, leaving me with 5x minus 3. I will get my highlighter out because it is still exciting to me that I got a set of identicals. Combine your greatest common factors and one set of the identical. And what do you know? We also got the same answer as here and here. So the ACB chart will always work. It just will always work.